Hey there! Today we're diving into the fascinating world of relative atomic mass. It's a key concept in chemistry that you'll need to understand. So let's explore how we calculate relative atomic mass for KS3 students. Ready? Let's go! Alright, before we get into the calculations, let's talk about atomic mass units, often abbreviated as AMU. These units are used to express the mass of atoms and molecules. Understanding AMU is crucial because it helps us compare the masses of different atoms on a relative scale. Now, let's get to the fun part: calculating relative atomic mass. It's all about averaging the masses of an element's isotopes, weighted by their natural abundance. Don't worry, we'll break it down step by step, so it's easy to follow. Alright, let's dive into some examples and practice problems to really get a handle on relative atomic mass. First, consider the element chlorine. Chlorine has two main isotopes, chlorine 35 and chlorine 37. Chlorine 35 is more abundant, making up about 75% of chlorine atoms, while chlorine 37 makes up the remaining 25%. To find the relative atomic mass of chlorine, we need to consider both the mass and the abundance of each isotope. So we multiply the mass of each isotope by its relative abundance and then add those values together. For chlorine, that means multiplying 35 by 0.75 and 37 by 0.25, then adding those results. Let's do the math together. 35 times 0.75 is 26.25, and 37 times 0.25 is 9.25. Adding those gives us 35.5. So the relative atomic mass of chlorine is 35.5. Now let's try another one. Consider the element carbon, which has two stable isotopes, carbon-12 and carbon-13. Carbon-12 is much more abundant, making up about 99% of carbon atoms, while carbon-13 makes up just about 1%. Again, we multiply the mass of each isotope by its relative abundance and add those values together. For carbon, we multiply 12 by 0.99 and 13 by 0.01. Doing the math, 12 times 0.99 is 11.88, and 13 times 0.01 is 0.13. Adding those gives us 11.91. So, the relative atomic mass of carbon is 11.91. I hope these examples help clarify the concept. Now it's your turn to practice. Try finding the relative atomic mass for elements like magnesium or silicon using the same method we've just gone through.